So, welcome. This is the workshop name called Data to Science. And we are going to be working together for the next 4 hours, doing some exciting stuff together. And this is the project that is funded by USDA HTP, coconut grant. So we got some seed money from there. And also we got some seed money from Purdue University School of, the College of Agriculture. So, we really like to, acknowledge the support from these two funding sources, which made it possible to, work on this project. So, all the material that we're going to cover today is available at the, the URL that I listed at the top, docs.gdsl. By the way, GDS stands for Geospatial Data Science Lab, my research group's website, .org, and Data to Science Engine Workshop. Or you can just scan this in the QR code. And if you just type that in, and you're going to land on this page, I'm going to just go back to that QR code later. I know that, okay, you're taking pictures. So if you want to come and have a bookmark, just do it. And this is the actual the workshop documentation page. And we have some introduction text about what this workshop is all about. And probably all of you are using UAV data, and probably that's the reason why you sign up with this workshop. And you know that the UAV data is great. You're going to get very high resolution, high temporal resolution data that's being collected. But one of the biggest problem is how you're going to actually manage the data. How you're going to store the data. How you're going to analyze the data, visualize it. How you're going to share those kind of data with the others. And that is becoming more and more issues where you start to get a lot of UAV data set being collected. So this project, the funded project funded by HTP and the Purdue College of Agriculture, is to develop an online platform which helps you to solve those kind of problems. And we decide to name it as Data to Science. So basically the meaning is that you're going to collect a lot of data, and how we can convert this data to solve your problem in science. So we like to be the the bridges between these two disciplines, data science with the actual science that you're working on. And if you can read it. And by the way, this is the written in gift books. At the bottom of the page, there is always a link to go to the next page. So if you click this here, you can meet the instructor today. My name is Jinha Jung. I'm a faculty member at the School of Civil Engineering here at Purdue. And our first instructor is going to be Hancock. He's going to be the one who's going to be covering how to deploy this Data to Science online platform to your laptop. Or if you like to deploy it in more shareable way, you can deploy in the public cloud or CyVerse. Any of these the public cloud services out there, and we're going to demonstrate that with CyVerse and Anvil today. And Dr. Jung, Minyoung, she's going to come in at the last hours to talk about how to use this online platform. So this is going to be 3 of us who's going to doing this workshop. Quick housekeeping items. This is going to be agenda today, 2 to 3. Ben is going to talk about, Docker 101, because we just developed this online platform as a formal container, so that it's going to be very easy to deploy in many different computing environments. And next hours, Ben is going to talk about how to build the Docker images from the source code. So this is going to be an open source online platform. So any source code that we develop is going to be available on the GitHub page. So Ben is going to talk about how to build the Docker images from the source code. And we're going to take a 15-minute break. Then the last 45 minutes, then we're going to talk about how we can use that Docker images that you build from locally and deploy it in your local machine and other machines. And also we have a Docker hub repository available as well. So the easiest case scenario is even you don't need to build any images. You can just pull these Docker images directly from Docker Hub, and you can just deploy with a single command line. So of course we can make this workshop very easy. All you need to do is just one command line. Probably you can just do it that way. But we like to use this as an opportunity to teach you how to go all those magic behind. We like to share all those secrets behind it so that you can familiarize yourself with it. And the last hours is going to be, like I mentioned, earlier, Dr. Minyoung Jung is going to coming in and demonstrate how to use this online platform. So with that, I'm going to pass my microphone to Ben so that he can get started. Ben, I think this is a mic that you can use. So you have any question? This is going to be part of it. So we haven't studied a kickoff meeting yet. Probably this is the outside of the conversation.
I was confused. Sorry to say that, but half the time I was figuring what is DS2, what is DS2. I didn't get a clear.
Yeah, it should be.
In the agenda.
Probably there was a.
Science would have been.
Yeah.
More attracting more people. I was
sure.
Half the time I was breaking. What's DS2 is what it is.
I think we typed in D2S.
So that is
yeah.
different, not. But this is an introduction to that.
So the Egg Biodata Working Group, the title of the working group is Phenotyping Data Standardization and Management. So we're going to have 3 subgroup in there. Data standardization, data creation, generation, and data management. This data to science is one of the data management system we're going to talk about. This is not the only one. Yeah.
That's one. The second question I had is, I know a few months back, there was this pipeline developed by Purdue that could handle multispectral, hyperspectral LiDAR data together. Is this the same or it's different?
I think there are many research scientists at Purdue. I'm not sure what exact
So
pipeline.
Dr. Yang was involved, and I think.
I mean, Dr. Yang is part of our collaborator. We are going to be integrating the field sampling data set and also greenhouse phenotyping data into this platform. We don't have it yet, but we are planning to incorporate it into our platform as well. Yeah. Okay. Can you get started? So I'm assuming this is going to be interactive. So please bring your laptop out. We're going to have a lot of, not so much of coding, but do some software installation, and you're going to have a lot of hands-on activities in this workshop. So, hey, Ben, take it away.
Okay. All right. So we use Docker pretty extensively in this application. So we'll start there. Has anyone ever worked with Docker before? Okay, a few of you. So just briefly, Docker is basically a technology for taking your application code and putting it into an isolated container. So with Docker, you're able to create these containers that not only have your application code, but it has all these system libraries that your application depends on. It has all this environment settings. All that goes into that container. And so for our application, I should say, our application is called Data to Science, but it's actually made up of many different services that support that one application. So in our case, we actually use 8 containers for this entire application. And the great thing about Docker is each container can have its own very unique environment that's suited just for that service that it's running. And so I will pull up, because this probably sounds an awfully lot like a VM. And so here's a comparison that the Docker put together of a virtual machine and a container, because they sound on the surface level pretty similar. You're creating an isolated environment with a very specific environment set up for the needs of your application. One of the big differences, though, with a virtual machine is with that you're installing the entire guest operating system. So let's say your application needed a Linux operating system like Ubuntu 20.04 or something like that. In your virtual machine, you'd be installing that entire operating system. You'd have to be setting aside resources for it, so you'd be allocating a number of CPUs, amount of memory to it, amount of disk space to it, and all that, which means that virtual machines can be kind of resource heavy to run. And they can take a while to build because you are rolling out that entire operating system. While the Docker stack looks similar, the big difference here is instead of having that hypervisor layer, which is basically creating the virtual hardware for the virtual machine, we don't have that. We have Docker Engine. And unlike with the VM, where you're very isolated from the guest operating system and the host machine, Docker containers kind of run like other applications on your system. They're very much in communication with the host machine, and because of that, you don't have to install the entire guest operating system, which means you end up with a much more lightweight environment. So both of these serve a role, and actually virtual machines and Docker containers work really well hand in hand, and that's kind of what we've done with our deployment. So when we get to talking about that, I'll kind of show how we use both of these. But I just wanted to kind of highlight the difference between Docker container and virtual machine. Mainly, Docker container is a much more lightweight environment and uses much fewer resources. And so a few terminology, keywords that we'll be discussing today. We're going to be working with something called Docker Desktop, which is the kind of user-friendly desktop application that Docker's rolled out. This is probably the easiest way to get Docker installed on your computers these days. And when you install Docker Desktop, it's actually going to, I should say Docker's not just like one single tool. It's actually a whole suite of different tools that serve different roles within that Docker ecosystem. So when you install Docker Desktop, it's going to be installing Docker Engine and Docker Compose. Those are the two tools that we'll be mostly using today. Docker Engine is what we're going to be using to build and run Docker containers. And Docker Compose is kind of an orchestration tool for if you have a multi-container application, such as ours, which has 8 containers. Docker Compose provides you a tool where you can interact with a single config file that describes all of your containers, and with just a few commands, you can start up all those containers at once and kind of orchestrate that, bringing them up, bringing them down, and building them.
Sorry to interrupt.
Yeah.
How many of you use Docker before?
There's a few.
Okay, few. Okay.
Yeah.
I'm glad that at least all of you have not even heard about, because there are many cases where I encountered a case, I haven't even heard about Docker at all. But I'm glad that they're already.
Yeah. In the last few words, so Dockerfile, this is our kind of our instruction sheet for building a Docker image. And what's a Docker image? The Docker image is basically that blueprint that so the Docker file is going to describe our entire environment. So it's going to always typically start with a kind of like, what operating system do you want to be the baseline for your environment container? Then you're going to put all the instructions for, here's how I want you to copy over my application code. Here's what dependencies on the system I want you to install. Here's some environment variables that I need. So all that gets defined in this Docker file. Then Docker Engine is going to take that Docker file, and when we run the build command, it's going to produce a Docker image. And so that's kind of the blueprint that Docker will then use for creating that container instance and running it. And then lastly, the container. And so that's just the instance of your Docker image. That's the self-contained environment that you've created with your application code and all the environment settings and system libraries that you need. So that's just kind of high level of what Docker's doing. And another reason we went with Docker is because, like, from the very get-go, we wanted to have this application running inside containers because Docker's very portable. So that means we can take these containers and deploy them in many different environments without having to make any major significant changes to the code itself. So with that, we'll just move into installing a Docker Desktop. So like I was saying, this is the easiest way now to install Docker onto your computers, and it's going to automatically install Docker Engine and Docker Compose. There are somewhat unique instructions depending on your device. Let's see, how many of you are Windows? Anyone? Or is everyone Mac? Okay, yeah. Got a few Windows and mostly Mac. So in both cases, I'll just have everyone go to their respective documentation for installing a Docker Desktop. These links.
So has everybody
Yeah.
have access to this document, the documentation page?
I would love to follow along, but I can't do this with an ARS computer.
Okay. You're recording this.
Okay.
We're going to later on go into our YouTube channel so that you can watch it live and follow.
We can use work laptop.
So
Oh, okay.
But you have a personal laptop, right? You are Mac, and
Yeah, I can pull that. Oh, wait, QR code. There we go.
so it's a docs.gdsl.org /data to science engine workshop.
I'm not authorized, but I'm not sure.
No, you have to type in full. If you just go to the docs.gdsl, this is a private individual where you're going to get uniform login, but you can type in full address, which is right. So you have an access to that documentation page?
Yeah.
Okay.
Everybody here? You're good? Good. So this is going to be hands-on workshop, so we're going to go pretty slow. So you may think that, oh, this is so boring, but we have 4 hours.
Yeah.
I'll leave in an hour, I'm sorry, but I'm curious to hear for an hour.
Okay, so can we just move forward? So
Okay.
you have a Windows, Mac, Windows. Okay.
So those that have heard of Docker, do you already have Docker installed on your computers, or does everyone need to install Docker Desktop? Done it. Okay.
Let's do it. By the way,
Yeah.
we have a couple of instructor here, so if you have any problems, just raise your hand. We'll be there and help you.
So I'll just pull up the Mac instructions since I think that's what mostly. But if you go to the page in the Git book for which required software you have, Windows, Mac OS. So the first step is going to be going to that link right here for the official instructions, and you should see a pretty big button right there up at the top for downloading Docker Desktop. And it's going to be a pretty straightforward installation. You could just leave it on the default settings. You probably will need to restart your computer after you install it. But other than that,
So for the Mac, you need to, if you have an Intel CPU,
Right.
you need to download the Intel chip version. If you're in the M1, you're in the Mac silicon chip, then you have to download the silicon chip. I think on Windows, we have one.
yeah, there's this one, and there's some other system requirements, but I tried this on like a fresh install of Windows 10 yesterday, and I was just able to download just Docker Desktop EXE, go through the installation just fine. This could take a few minutes, so I'll let everyone work on that first.
Take about 5 minutes
Yeah.
so that everybody can install this Docker Desktop. So probably everybody's downloading it right now.
Yeah, I don't know about the internet speed we have here, so some of these are big files.
Probably. How big is the file? 500?
Yeah.
Maybe a couple of minutes? And the installation should be pretty straightforward. Windows, just click that section as well. And agree. Onto the finish button. And Mac is, I have installation long time ago. Mac is more like a drag and drop.
I think so.
So let's give a few minutes until everybody can install this Docker Desktop. Already have a Docker Desktop installed?
Okay. Yeah.
We're ready for this workshop.
Yeah. Yeah.
Just curious, with Mac, can you do AirDrop or
What is that?
AirDrop, for sharing the file?
Yeah.
You can do it with Mac?
I think it only works for Mac though. Even the Mac. If you iPad, iPhone.
Let's see.
The procedure changed somehow if I'm using Mac or Ubuntu, or it's the same thing?
Yeah. So in Linux, I typically don't install Docker Desktop. I just install Docker Engine, which is like the command line tool. It's just when you're working in Windows and Mac, it's just a lot easier.
Sorry, I mean about the script. Because I mean, I'm using Ubuntu, so...
Oh, okay. Yeah, our Docker Compose you should be able to build on whatever environment you're on. Yeah, we just sorted something out with that this morning, but you can specify basically what build environment you want, so it's going to tell it to build in like Linux, x86, 64.
All we need is Docker command line.
Right, yeah, because we're not really going to be using Docker Desktop today. We're going to be using Docker Engine from command line and Docker Compose, but Docker Desktop's just the easiest way to get both of those installed. And which it is supported now by like Ubuntu and stuff on Linux.
One bit I had other question. So this is stitching. Is this stitching software with drones, or is this after stitched? After it's stitched, you're extracting.
Okay, guys, usually don't like these words for stitching, so you're not stitching. Because
Ortho mosaic.
yeah, ortho mosaic is not stitching anything. I'm dramatic.
Okay.
I'm kind of
Sounds good.
very,
Picky on
picky
terms.
about, picky about the term.
Yeah, yeah.
Probably you are doing the same whenever I talk to every person as well. But the stitching is when you say stitch goes together. But ortho rectification is a lot more complicated and different because
Yes.
that is
So this is after that.
after we have ortho rectification is generated.
So what's your product preference for the
It can be big for you, it can be editable, it can be, the open format, it really doesn't matter.
Okay. Have you tried it before? Different products. And also,
Personally, I like that editable, you can use that Russian.
We're not allowed to use any software anymore, so I guess.
Yeah.
and you're willing to create shape files?
I mean,
What is the pipeline of this is what I'm asking.
so we use editable fix for the open format to do the order rectification. Once they have order
There's water or anything.
from there, data format where you don't need to download the data, you can stream the data. Like for YouTube, you're not downloading the video anymore. You're streaming the video. You can fast forward. You can start watching from the middle only to the part that you like. You can go to the system, and we can do exactly the same thing we did for the data as well. So we have all those the cloud optimized the data format technology implement the backend. Once you put your data on this platform, now you can access this data pretty much anywhere.
So you need a host place to host your data.
So this workshop will teach you how to deploy on your local lab. So that you can use it whenever, whoever you are in on the same local network. But when we deploy this into the server, the Purdue, we deploy it in CyVerse. We deploy in Anvil. Anvil is another composable high-performance computing platform as well. So once you deploy these services on cloud, now you can access this like anywhere. And we're going to talk about all those details. I'm proud I'm kind of doing some of this from all the layer interface. Probably is going to stick to do it. That's what overall what we like to do today.
I'm gone in 20 minutes.
Please watch our video.
Sounds
Everybody was able to install Docker Desktop? Everybody good? Still downloading?
Still down.
Few
Okay.
minutes.
Yeah.
We can have some conversation here. I mean, I like to learn. You're from US. I think we met before, right?
I believe so.
Yeah.
Yeah.
So, where are you from?
Washington State.
Washington State University.
Tennessee State University.
Tennessee.
South Dakota.
South Dakota.
South Dakota.
South Dakota.
USB, Fargo, North Dakota.
North Dakota.
University of Florida.
Florida. Yeah. Pretty much all over there. I didn't ask that question. They all come to me. So, you guys all use a UAV for your research? What kind of platform do you use to manage the data? How do you manage your data? An hard drive? Some kind of cloud?
Some on the cloud, some on an external hard drive. We're looking for a solution like this that
We need to talk.
Yeah.
Yeah, sure. How about anyone else would like to share your experience, how you're managing your user data? I mean, I used to be in Texas A&M. I think I was there for 5 years, and we managed to accumulate almost 160 terabytes of data within Texas A&M. I'm not talking about 160 gigabytes, 160 terabytes of data. And imagine that how are you going to find the data? Even finding the data you want is heck of a lot. A lot of data formed many years ago. You don't know how to find it. Because probably you came up with some kind of order structure at the time you started. But we are all forgetful. A few years back, you trying to find it, you don't remember where it's stored. So, hopefully this is going to be the problem that we can solve real problem. So still downloading? We're going to go slow.
Okay.
Because the Ben was in a conflict. If I just doing everything on his space, then you can finish everything in 30 minutes.
Yeah, less than that. yeah.
So,
If things go smoothly.
yeah.
Um,
I just want to make sure everybody is on staff. So we're gonna go slow.
And one of the downside of the raw image is once you also mosaic, it's going to be over gigabyte.
Yeah.
So that's the lot of data loading and processing, and then making another processing immediately, doing the image extraction. So there's a huge computing load in there. So have you think about tile image base instead of stitch image base?
So I'm not going to steal thunder anymore. By the end of this workshop, you're going to say that I don't need to worry about this anymore.
I don't need to
Worry
about the
about
stitching.
Yeah, I mean the tiling.
Tile?
Because tiling is already kind of built into the data point that we are talking about. So I have so many examples where individual auto mosaic file is. I'm not even talking about 10 gigabytes, hundreds of gigabytes. I can load it in QGIS in seconds. We're gonna show you. I'm not gonna steal the thunder with a later instruction anymore.
Your raw data has.
But what if we have all the features extracted into Excel sheet? Then you never go back to your drone images, right?
I mean, yeah, that's way outside of this workshop, but this is exactly that working with you're talking about phenotyping data standardization. Because once you go to the Excel spreadsheet, data standardization becomes so critical. Everybody has their own way of organizing your spreadsheet. Somebody uses terminology A as a safety, somebody says E, and etc. And how you're gonna store your row major order, column major order, those kind of stuff. So we are planning to address this kind of problem in this online platform that I told you about. Right now we're gonna only support the UAV data for now, but we'd like to have field sampling data. We like also have the in-house phenotyping data, because you have huge going check go sample where we are collecting all those terabyte of the phenotyping data every day, which has no geospatial information in it at all, other than individual plant level and ID. So how we can incorporate all those kind of stuff into a place where we can find it, visualize it, analyze it, and share it. So this platform is all about this fair principle, findable, accessible, interoperable, usable. I don't have an answer for that one yet, but probably next year in NAPPN, we might have an answer for that.
While we are waiting, please let them know when you're done. Ask more questions while we are waiting for you.
Sure.
Few seconds
Yeah.
left, yeah. So you still need a host, right? So Purdue has a database, if I'm not wrong.
Purdue has we have our own server.
Server
Hosted
where
in the
you
Purdue
can store the data,
Yes.
and it's accessible within Purdue.
No.
It is
Anywhere in the
accessible, but if I'm not wrong, things are changing, you want us to load our data, would it, because it's cost for me at the end of the day, it's cost, and we are talking.
Be careful what you say.
Yes.
We deployed one instance for this workshop, and everybody who is participating in this workshop will have an account, and you are free to use how much space you want. So I think that this is the part that we're going to provide as in a workshop participant.
Come again, sorry?
You can use you can unload as much data as you want.
Load or run?
Unload. You can unload, for example, you decide to unload 2 petabytes of data. Until it becomes a problem for us to manage it, we're going to let you use it up to whatever storage you would like to use.
But what's the trade-off of that? I mean, this data, once we upload it in your server, this data is still ours, or this data is now shared?
You have full control. You're the owner. We're going to talk about it. So we're going to have the
It's going
full.
to become like CyVerse, sorry
Yeah.
to say that.
But CyVerse is more generic computing infrastructure for everything. What we
Yes,
are
but
talking about
eventually
here.
they started as a free thing, but eventually somewhere it is cost.
Yeah.
Data is cost. So storing data is also cost,
Yeah.
right?
There's no such a free thing for forever. There is going to be a certain moment where
Yes.
we cannot do it for free.
Yes.
We have to change our policy or something, but this is I believe small enough group where we can open up, where we can just use it for your research. And we are also working on writing back to USDA and NSF, and hopefully we can just do it at the national level, provide this kind of service for other universities. But I will say that the participant who is in this room right now, we're going to create another account in one of the instances that we deploy, and you'll have freedom to choose, freedom to unload as much data as you want.
This is being recorded.
We are recording.
I'd love to follow up with this.
You're going to be around.
Yeah, I will.
I'll be around this.
Thank you, Dr. Johnson.
You're done?
That's not. Yeah. For those who have installed it, just make sure from like a terminal, you can run Docker run hello, which is just going to pull in some Docker image for testing that out. And then the Docker compose version, and just make sure you get back some version number.
So can you show that
what that looks like?
on the screen so that somebody who already has Docker installed?
Right. So we're going
Can you
to
increase the font size a little bit? Control plus, I believe.
let me try that.
Yep.
Well, that's a little better. Okay, there we go. So you can see I didn't have the hello world image local, so it pulled it in from a remote source from Docker Hub. It just gives you a little bit of feedback there. So that's just going to let you know Docker is up and running and able to run containers.
What about Windows? I think in Windows you have to open a PowerShell.
Yeah, Windows, I would use PowerShell. When you install Docker Desktop, it's going to make all these commands available to you from command prompt would work also, but PowerShell is probably a little more fun to work with.
Open up a PowerShell. If you click the stop button, there's PowerShell. Windows Docker run hello world.
Yeah, hyphen between hello and world.
Hello world is hello dash.
I will say you have to have Docker Desktop running in the background as well because that's going to be managing the Docker service behind the scenes.
Yeah.
And
until we can distribute and make sure that your Docker is running.
this brings up a good point too. So one of the nice things about Docker is we're going to be building a couple images locally, but like I said, we have 8 containers. 6 of those, or 5 of those containers actually depend on just remotely hosted open source projects from Docker Hub, which is a central repo for Docker images. So like if we need an Nginx web server for our application, we don't have to go through the process of building that container ourselves, or the image for that container ourselves. We can just pull it in remotely from the Nginx public open source repo on Docker Hub and make use of it. And that's what we were doing here. It's like we didn't have any code for building this Hello World container. It just pulled it in remotely and built it here on our local machine. And the other command I was suggesting to test out is docker compose. So just make sure you can run docker space compose space version. You should get back something like 2.23, or it's probably dependent on your system a little bit. Yeah.
Error message, I don't know how to.
Oh, is it a win?
So it's running Docker behind. Do I have to log into the iCloud?
No,
right?
no, you shouldn't have to. Yeah, it doesn't seem like. Can you go to Docker Desktop? Yeah. Oh, see, it says the engine stopped. Yeah, you should be able to close out of that. Yeah, I don't know why it keeps. Yeah.
Now you have to sign in, right?
No, you don't have to sign in for this.
Keep asking for sign in.
No, I didn't sign in.
No, yeah, that's just if you have like stuff hosted on Docker Hub, you can hook up.
Okay, just stopped.
I think you might just need to restart the application.
Just kill it.
Yeah, it seemed like it. Did it have you restart after you installed it? You did. You did. Okay. Because it seems like it's kind of hung up. I don't know if one more restart might just be the.
Taking this long to load desktop?
You should at least see Docker Desktop, and then it would tell you that it's starting the service or something like that. Because that part can take a little while, but it should be giving you feedback that it's doing something.
It's not running.
Yeah, it doesn't seem like it actually restarted the service. Yeah.
Maybe.
Maybe restart again.
Is that the resource folder?
Oh.
You have to kill this manually?
Yeah, it didn't cleanly shut it down.
How do I kill it?
I think right click it and
process?
yeah, tree probably, because you want it to stop all that. Okay.
Engine stopped. That's net, right?
Huh. clicking. Let's see, could I?
This probably is a little bit outdated.
I mean, I got to work on my like 8-year-old laptop the other day. See, what I don't get is it's not even trying to start. Let me. No, I don't want to quit. Let me tell it to restart.
When you open Docker, what screen do you see?
Yeah, this one.
That's it.
Yep. Yeah, Docker desktop.
It's Docker engine start on my screen.
Yeah, and I didn't want to start it either when I.
Sorry about that. Probably we have to go. Move
Try
forward.
I would just restart your whole system again and see.
We started already, so maybe.
Yeah. Okay.
And let's make sure that you were able to run the Docker run hello world on the Docker Compose version.
It's going to take a while to build the application, so we'll have time to catch up if anyone falls behind a little bit. Okay, so it seems like most everyone's got a Docker desktop installed and running now, and you're able to run Docker Compose and Docker Run. The only other recommendation we had, we're not going to be doing any coding today, but we will be opening up some Docker files and looking at some environment setting files. So if you'd like to get a code editor or something, you could use something like Visual Studio Code, but if you just want to use like text editor or Notepad or whatever you have on your system, that'll work fine as well. Okay, so at this point we have Docker running, so we've gotten to the point where we can actually start to build our application. And so we're first going to go through this iteration of building it from the application source code. So like we said, this is an open source project, so anyone can go to our GitHub page, download the source code. It's going to have all the necessary Docker files right there for you to use in order to build the application and deploy it on your own machine. And so, as I was saying, here's what we kind of have two versions of the application. We have a development version, which has a couple containers that provide some handy tools for debugging and looking at your database and following processes. So the blue ones, though, are the required ones that make up this application. So we have a front end, which is a React application. So it's a React, which is a JavaScript framework. So that's what's serving the front end. For the back end, we're using Fast API, which is a Python framework for creating APIs. And it's a great framework because it automatically generates documentation for you for the API and like the open standard. So as you build it, it's going to put all that documentation together for you, which helps out developers and people who might want to interact directly with that API instead of through the front-end application. Then we have a Celery worker. So we do some processes that they take too long for you to wait in your browser for that process to finish. Like we don't want you to hit run and then just wait 10 minutes while some major conversions going on in the background. So we use that Celery worker to send these tasks that require more heavy processing. We send those to the Celery worker, it works on them, and then it just notifies the front end once that task is done, so you can see that the progress has been made and it's completed. So database, we have a Postgres database with PostGIS because we're storing spatial data in there. Redis is just a message broker, essentially. This is for communicating those processing tasks between the backend and the Celery worker. And then Flower is just a visual tool for looking at Celery worker, so you can see how many tasks have been submitted, how long they've been running, which ones completed, which ones failed. And then pgadmin is just a visual tool for your browser for exploring your database, so you can look at all the tables and see what data has been populated in those in case you don't want to go through the command line. But all these containers, and Also, the one thing with the Docker containers, they're all kind of sharing the same network space so they can communicate with each other. So the front end is only in communication with the proxy, but then we have the back end, which is communicating with Redis and the database. And then Redis is sending those tasks, processing tasks onto the Celery worker. Celery workers connect to the Flower, which is the tool for visualizing it. And then at the very top of this, we have is a proxy. So this is basically our single access point to getting into the application. And we can talk about that in a little more detail later. But that's the basics of how this application is organized. So at this point, we can download the source code. So in the book, Gitbook, if you go to the obtaining source code page, we have a link to our GitHub repository. Once there, you can click on that green code button and download a zip, which will download all the source code to your system. Well, I should say, if you're on Mac, it might automatically unzip it for you. If it's still in the zip file, you'll need to unzip it. And inside it, you should find a folder called data-to-science-main. And that's the folder we're going to work out of. You know, just put that anywhere that you want to serve as your workspace. I will give you a few minutes, though, to get that downloaded and unzipped if needed. And I can... Working? Good. I don't remember, I think it's around 100 megs for the, I think it's around 100 megabytes right now for the source code.
Okay.
Yeah. So, did Docker engine ever start for you? It is working now?
Yeah.
Okay.
Actually, it was just logged out, not to reboot the computer.
Oh, you just logged out and
Yeah, I think that's what happened.
okay. Do we need a few more minutes, or does everyone have the code downloaded, unzipped? Unzipping, okay. All right. Okay. Yeah.
It's my first year working in agriculture department.
Okay.
So you are a student faculty? I'm a postdoctoral researcher.
You said you're from Washington?
No, University of Florida.
Florida.
Yeah. It's my first time working with agriculture. Before I worked with multi-representation, I worked with
We're good? Okay. So we're actually ready to build the application right now out of the box, but we do have a few environment files that you can use to customize how that application behaves. So we'll kind of go over those, but we're not actually going to change anything inside these files. But the first file we want to take a look at is inside that directory you just downloaded. You should find a file called backend.example.env. Go ahead and copy that to a new file named backend.env. And then there's one other file, db.example.env. You'll want to copy that one to db.env. So you should have two new files in that folder. And it should be, there should be a .example one in the folder that you're going to rename to, just remove the example from the file name. Yeah.
What we need to copy this file for that folder?
Why are we copying the, to a new file? Well, basically, because for the example, I just wanted to have some like dummy values in there, but I didn't want anyone actually like necessarily deploying it. It's just to give you an idea of here's what's expected, but then make you consciously copy it to a new file because that's what's going to be used when it builds.
Can you show the a bit more specific instruction on how that works? I think you can show it from the File Explorer. I think it will be a little bit.
Oh, for file. Okay, projects. Right, so this is that root directory that we just downloaded. Inside it, you should have a file called backend.example.env. You just want to copy that one. Like, of course, mine looks different, so copy. Then we can paste it. Depending on your operating system, it's going to tell you the file already exists, and just rename it, though, when you to backend.env. And then just repeat that process for the db.example.env, name it db.env. And the other reason we do this copying process is because you put secrets inside these files, so like your database password and things like that. So if you're working with GitHub, you don't want to commit those files accidentally to GitHub with your secrets in it. So with this, we have it set up to ignore db.env and backend.env, so they never get committed into the repository. Okay. And like I said, you don't need to change any of the value here. I've opened up backend.env. You can leave all the default values as they are. But if you wanted to change the project name, we have a variable for that. So if you typed in some other value instead of data to science, that would appear as the title. The domain, we're going to be running this locally, so you don't want to change that. But if we were going to host this on a different domain than localhost, we could use that. Celery broker, so that's, as I was saying, we're using Redis to kind of communicate these background processing tasks between the backend and the Celery worker. So this is just the address for where that Redis service is running at. So Celery will know how to communicate back and forth over it. And then email, so by default, we have this set to mail enabled 0, which means no email support. If you set this to 1 and you had your own like SMTP server for serving email, we do have a system set up so when someone registers an account, they'll have to do email confirmation with their email address. Whoever you designate as the admins will get an email that saying they need to approve it and so forth. So we do have some like basic email communication, but if you don't have an SMTP server, or you can just leave that on 0, and basically you create an account and you go straight in. So we just leave that on 0, and then secret key is an important one. Since we're just running this locally to test this out, we don't have to worry about this too much. If you leave it empty, a secret key will automatically be generated for you. But this is basically, this isn't an application that has user accounts. And so in order to authorize users and keep track of who's who whenever someone's making a request to the application, we use something called a JWT token, which is basically just a file format that contains information about who the user is. And so we sign it with a secret key and send it to the client. And then whenever the client makes a request back to us after they've signed in, we'll check that token and see who it is that just made that request. And we can also use that secret to see if any changes were made to the token and then reject the request. But like I said, for today, just leave it empty, and it'll randomly generate a long key for you in the background. And then for the database,
Quick question.
yes.
Going back to that example.
Yep.
The reason why you're leaving everything blank is because you are doing it locally. But when you're deploying this onto the server, you don't want to do that, because that is basically anybody can hijack your system. They can just do whatever they want. So.
Well.
Yeah.
And it'll make a key for you, but that key is going to change every single time you redeploy the application. So anyone who had previously signed in with the old key and then they try to do something on your site, they're going to get some permission errors. So you want it to be static and safely stored somewhere.
So we set up the main enable as a 0. So right now, later when we actually use the system, when you sign up, you're not going to get a confirmation email, but they're going to approve automatically?
Automatically. You just go straight into the system. Yeah.
But the actual instance that we deploy where we have to approve you. So that's the what I was talking about earlier. We're going to approve your account after this workshop so that we can use this one for research. But no one else is going to be actually.
Well, I think today you'll be able to just go straight into it, and then after this,
So
it'll.
NAPPN doesn't have any email confirmation?
Not right. Well, we can. Yeah, we can change it before we go to it. It's easy to change. Okay, and then so the other environment file is our data.
Sorry to interrupt.
Yeah.
Going back to the backend example.
Yes.
So basically, instead of copying the example to the backend.env file, you don't have anything. You don't need to do anything today. So
You need to copy it to backend.env, but you don't need to change anything inside it. It's going to be the same case for the database.example.env. You don't need to change any, just copy it to a file called db.env, but you don't have to change any of these values. Obviously, if you're going into production or something, you don't want password to be your password. So this is where you could, like if you wanted to set your own personal password here, this is where you would change it, and then your database will have a user account called D2S, and it will have whatever password you've typed in, and the tables or the database storing all this information is going to be D2S. So you could rename this before you deploy it if you like. The only thing you really can't change is this host, and that's because of the Docker Compose file, which I'll talk about in just a minute. But this has a special connotation, this name right here. Okay, so I think we've covered this here. So you should have your db.env and your backend.env. And then the last thing we want to edit is that docker compose.yml file. So let me open that up. And again, we're going to leave these on the default values, but there's just a few more front-end environment settings you can change starting. So just here, I'll use this chance to kind of explain our Docker Compose file. So at the very top of the Docker Compose file, we have services. And then on the next level in are going to be all of our containers. So these are the service names for our containers. So we have a container named front-end, back-end, DB. So that's why we used that host name in that previous environment setting, is because it needed to match this name right here. And we do that because when we're connecting to the database from our backend container, we don't want to have to type in an IP address, because with Docker, the IP address, internal IP address for a container can change when you take the containers down and bring them back up. So by using this alias DB, we don't have to worry about that. It'll always connect to that database container. Then we have our container PG admin, Redis, celery worker, flower, and proxy. So those are our 8 containers that we have for this application. And then also importantly, we have 3 volumes. So one thing to keep in mind with Docker, data inside a Docker container does not persist. So if you take the container down and then bring it back up, anything you changed inside that container that wasn't there during the build is not going to be there any longer. So in our case, of course, we want our data to persist outside of taking the containers down and bringing them back up. Particularly, we want to have our database data stored somewhere on our host machine, so it's always there. We want to have our log data stored on the host machine, and then our user data. So all the files that a user uploads, all this is going to go into a volume on the host machine. But for right now, we just need to focus on the front end container, and then I will discuss the other ones, I think, while we build this application, because that'll take a few minutes. But again, we've got 5 environment settings here. The first one is just the shorthand to the API backend, which you don't want to change that. This is just so if we have different versions in the future, we can easily swap it out using this environment variable. We have the name of the application, shorthand version of it, our slogan, and then the domain. Again, we're running this all locally today, so just leave that on the local host. So just wanted to show that to you, but you don't need to change anything or rename any files for Docker Compose. So at this point, we're actually ready to start building Docker images. So you'll want to return to your terminal where you ran Docker Hello World and navigate into your folder that you downloaded with all the source code. So you should have this Docker compose.yml should be at the same level that you're currently at in your terminal. And then once you're in that directory, you're going to want to run docker compose build, and this is going to start the build process for the application. In my case, it's going really fast because one thing about Docker is it's going to cache each step of the build process. So on subsequent builds, it'll go, yeah. Right, you can see cached right here. So unless you change an instruction inside your Docker file, and let me pull up the Docker file so we can see what's happening here. Oh, yeah.
We are using the Docker Compose .html, right?
The YML, yeah.
Because it's pointing to the backend environment, not to the example. I should change that, right?
The environment file?
Yeah, the environment file is the default one is the backend environment, but we copy the example one, so we should change the name of that, right?
The backend, yeah, you want backend.env. Yeah, you should have a file backend.env and db.env in your directory. So is everyone able to get it building at least? Or, Okay. So,
Your build process is done?
Yeah.
Okay.
yeah.
So I think he's running it. So let's do 3 more minutes.
Oh, I was going to kind of talk about what's going on right now. So in that Docker Compose file, so when we ran Docker Compose build, it's looking at the Docker Compose.yml file, and that's telling it that we have this multi-container application, and it's describing how to set up all these Docker containers. So for the Docker containers that say build, and then they have context and Docker file, that means we're going to be building that locally. So this front-end container is going to be built using the Docker file located at front-end directory and then a file called frontend.dockerfile. So that has the instructions for building the Docker image for this front-end container that's going to be used to then start the container. Similarly with backend, we also have a file for that one. So that's being built locally. But then like for our database, you can see we don't have any build instructions. We just have image, PostGIS, and that tells you that we're pulling this in remotely from Docker Hub in this case. So anywhere you don't see the build instructions, there's no associated Docker file in our application. It's just going to pull that in remotely.
So can you explain what is that Docker Hub thing is? Because probably there's some people who doesn't know what is Docker Hub.
Well, we're going to use that to build on the next step, right? But I can pull that up real quick. So if you're familiar with like GitHub, GitHub's a popular repository for storing source code. Docker Hub's kind of a popular place for a repository for storing Docker images. So after you've built your Docker image and you want to share it with other people, you can publish it here in Docker Hub, and then anyone else can just pull that image in. They don't have to build it themselves. Like they don't have to go through the steps we're doing right now. They can just pull that image in remotely and run it, kind of like you did with that Hello World application example earlier. And so we're hosting this application also on Docker Hub. So after we build it locally, then we're going to show you how you can like really speed up the process by not even needing to build it, but just using our remote images and run the application. And let's see, is it still building for everyone? It might take a little while, or is everyone finished? Still building? So what's happening? So with these Docker files, like I said, it's building based on these Docker files we have. This is the one we have for our backend container. So every Docker file is going to start with this from line, and it's going to declare some base image. So this is kind of our starting point for putting this container together. In this case, you can see our base image is Python 3.11 Slim, which is, I think it's a Debian Linux. It's just a flavor of that that's custom for Python, put out by the Python group. And so that one we're not doing much right here. We're just setting up a bunch of environment variables, but this is basically the image, base image that's going to make up our final image once we've gone through all these steps. And taking a step back, this is a multi-stage build. So we go through several build phases. It's often with your container, there's going to be some system dependencies that you have to install, but you don't need all the files that get created and generated while you're installing that application. You might just need like the binaries that get produced at the end of that process. So by using a multi-stage build, we can kind of install what we need at that stage of the build, but then when we get to our final build, we can kind of clean it up so it only has exactly what's needed for that application, and that kind of helps cut down on the overall size of the image itself. So here we can see the next stage. This is where we're installing the Python environment. We're using Conda to set up our Python environment that this fast API backend depends on. And so there's an environments file in that backend directory that declares all the packages that we need in order to run this application. And that's what's happening right here is it's installing all the items from that file. And then we move to our last stage where we're setting our working directory. We're creating a user to run this container, which is an important thing. With Docker, out of the box, if you don't declare any user for your Docker container, it's likely the Docker container will be running as the root user. But you often don't want your Docker containers to have root permission, especially if you're making a web application that's going to be like publicly available. So one of the easiest things you can do to a Docker container is to set a non-root user as the container owner. So whenever this container, Docker starts up this container and runs it, it'll no longer be running under the root user. It'll be running under this D2S user that we created that just has basic user permission level. And so that's what's happening here. And then you can see we're copying from that conda base stage of the build where we set up our Python environment. We're just copying over that virtual environment we created, but we're leaving behind all the extra stuff that was generated during that process. Then we're installing a few more system libraries like curl and GDAL for raster processing. Then creating a few directories that the application is going to expect inside that container, and we're changing the ownership to this new user, non-root user that we've created. And then the last command is starting up the script, which is going to start the fast API server. So most of that text you see during this build command is going to be from that backend Docker file as it's going through each of those steps we just saw and running them inside during that process. And is everyone finished building at this point, or is it? Uh-oh, one error. Yeah. Connection broken. I think it just timed out while trying, because those conda packages come in remote. Just try running it again. I think that's happened to me a few times. Sometimes these, like conda, the remote repositories, you get a mirror that goes down while you're installing it, which it should just zip right through any of the previous steps up to that point. It's still running, okay. Okay, yeah. Did it get past that part this time?
Yeah, I'm doing it again.
Is this, okay. Yeah, installing the conda packages takes a little while. Conda can be very slow. Yeah.
When you install the conda to Instructor, there was different version of the conda, mini conda or something different.
Yeah.
That's the command for the
We're using, this is something actually new to me, because I was always familiar with mini conda, but we're using Conda Forge, because a lot of the package we want is in the Conda Forge channel, and so Conda Forge has put out their own Docker images, so their own environment that comes with Conda installed already for you, and they call this Mini Forge 3, but you interact with it just like Mini Conda. It's the exact same commands, Conda create, Conda env, all that stuff's the exact same. This is just a Docker image that someone put together, so I don't have to manually install Conda myself. It just comes with that image ready for me to use.
one time I had an error with that, just the conda for the Unix system. So I had to install the mini conda.
Yeah, I've had lots of errors with Conda. Python packagings can be tricky. Or sometimes it'll take like 10 minutes to resolve differences in file version or library versions. We mostly went with the Conda because we have a few like system packages we use, like GDAL for processing raster data, and then we have PDAL, which is basically the GDAL equivalent for point cloud data. So using Conda lets us it's a really easy way to get those installed, and then we can access them from the command line inside our application.
But later when we use the images from the Docker Hub, we don't need to
All these instructions and what you just built right now is what's been published to Docker Hub post-build. So you don't have to do you don't have to run Docker Compose build, basically. You can just run one line and get the whole application up and running with 3 files.
there is an easier way when we take stuff, but whenever you guys are teaching the student, you don't want to show the easy one. You want to show the difficult one first, and show the easier later.
Like this would be the process you go through if you wanted to change something in the source code and then rebuild the containers. Yeah.
Do we take a break here?
Yeah, we could take a break.
Yeah, so I think everyone was, why don't we take a 15-minute break? So this is a 3:26, so let's start at 3:45 on that. Okay? You're going to stop recording. Can you say something?
Test? Good.
Whenever you're ready.
All right. Okay. So we can get back to it. Hopefully everyone's Docker Compose build commands finished at this point. So now that's all that's left to do is spin up the application. And so we can do that by running Docker Compose up. So if we run Docker Compose up, again from that same directory where the Docker Compose.yml file is, and then -d at the end, that'll tell it to run in the background. Otherwise, you're going to see a lot of log output right here in the screen. So then you should see a message. It's going to go through some health checks, and it'll say starting these containers and then running these containers once they're up. So one thing you can do to check on the status of all these containers is if you run the command docker ps-a for all containers. It's all a little bunched up on the screen, but you're going to see each of your containers running. You're going to get the container ID. Let me switch to this image here. You should see some output like this where you'll have the container ID, the name of the image for the container that it was based on, because all containers are based on some image blueprint. You'll see the command that was run to start the container, how long it's been running, what its current status is, if it's healthy or if it's failed or some issue. And then you'll see any ports that it's opened up or that's communicating over. And then you'll see just a name for that container, a plain text name. And if you're running Docker Desktop in the background, if you open up Docker Desktop, you can also see all this information from there as well. By going to that containers section up here in the top left, you'll see the folder name, Data to Science Main. That's kind of our namespace for all these containers. And then underneath that, you'll see each of these containers that you've started up with that Docker Compose up command. And you'll basically get that same information we were just looking at from the command line. So did the containers start for everyone?
Looks like they might need some help.
Right, because it's going to be Docker Compose up -d from the directory. That's it. So it's still starting them. Okay. I'll put a space between the S and the hyphen. Yeah, so it doesn't look like any container started. So run docker compose up. Oh, sorry, without run in front, just docker compose. And then space up, and then space -D. And this should start each container. Okay. Yeah, there it goes. One of the other things that's going to happen when you run that docker compose up command is it's going to pull in all the remote images for those other containers that we didn't build locally. So it does have a bit of downloading to do. And all these commands we've been running, like docker build, docker compose, they all run much faster the second time. Because after you've pulled all those images in remotely and they're in your local images, it'll check, see if it's available locally and use that image instead of going through that whole download process again. Same with the docker compose build. It's going to check if you've already built that exact statement before, and it'll just reuse it. So once that's started, you should see all the containers running, and hopefully the status should just say up for a few minutes, however long it's been up. And so another useful command, so we've seen docker compose up is what we use to bring up our containers, start them running with the Docker engine. Then we had docker ps, which kind of gave us a view of all the containers that are running, what their current status are. Another useful command is docker logs. That'll let us look at the log files being produced by any container. So if one was down or had exited unexpectedly, we can use the docker logs command to see all that information, log information. So if I say docker log or docker compose logs, and then the name of my container, so like say backend, we can see the just normal output coming from the backend container. If I say celery worker, this is the output coming from that celery worker container. So we can see that that started up correctly. It's registered our tasks that we're going to be running. And you can also get all that logging information from in Docker Desktop as well. So again, from that containers tab in the top left, if you click on the specific name of one of your containers, that'll take you to this subpage, and then you have a tab for logs, inspect, and some other information about that container. So pretty much everything I'm showing you from command line you can find now in this Docker Desktop application. And one last bit of information we can see, so we have that proxy container. It's kind of, let me shrink my text down. We have the proxy container, and we can see this 0.0.0, 8,000 to 80. That kind of tells us that we're mapping our local host on our host machines, port 8,000 to port 80 in that proxy container. So port 8,000 is what we're going to use to connect to the application, which should now be running on our computers. So to test that out, you just need to go to http://localhost port 8,000, which is being forwarded to port 80 inside the container. And well, I was signed in, but you should see this when you go to that page in your browser.
Yeah, it's an open door like to.
Yeah, so if you just type in the IP address and 8,000.
Okay. Which part you are in? Okay.
Is it downloading something right now?
Yeah.
Okay. Which is it downloading? The Redis. That's like 11 megabytes. Maybe it's just because everyone's trying at the same time. I don't know. It's still building. Oh, yeah. It was real.
You need to upgrade your laptop.
Yeah, it's the old one.
Well, until I switched the con.
Supposed to use this heavy computing.
Yeah. I don't know.
A few more minutes.
When you build Docker, where is that Docker stored? Is it on the local machine or is it on the cloud?
Local machine. This is all being run from your local.
That's a lot of storage.
Yeah.
It's taking up the 10 gigabytes.
Yeah. Well, one thing you can do, so in our case, like we were declaring these Docker volumes down here, and that's just basically, these are just going into your local file system. It's mapping somewhere on your local, on the host machine's file system to inside the Docker container at a directory we specify. So like in the case of the backend container where we're going to be uploading all of our big data sets, like you can see, I'm mounting this Docker volume called user data to /static. This could easily be any path on your file system. So if I had like network storage, something mounted to my local file system, you could map that into your container and store your data there. But yeah, no data is leaving this, and it's all just running on your local instance.
So you guys are still stuck on that
It was a 12 megabyte file. It was taking forever to download as well.
Really? Much higher rate. It's 112 MB.
Oh. Okay.
Which Wi-Fi you on? Is it guest network? Yeah. Okay. Something like that.
It's still 100 megabytes. Yeah, I mean, I guess I'm used to Purdue's network, unfortunately.
We're on different network. Because we're on a Purdue network, not the guest network.
Or the campus network, yeah. You take those things for granted. Which then built the next step where we're going to have them bring it in remotely. That's like several gigs for that remote image. So I can show them how, but not do it.
Expect it to follow.
Yeah.
Still 2 more hours.
Okay. Might take an hour to download it if we try that.
At the end of the office, that she might need a little more time than an hour, so maybe you can just quickly show that the remote images.
Yeah.
On the machine, and you're going to record it, so maybe they can just try and play that, watching the video.
Yeah. And we can show like Flower, how that's tracking all the tasks and stuff like that if we need to.
So we are done with this one, so probably we can demonstrate how to pull from node.
Okay, yeah,
So
we want.
you're building your own machine in your local. In that case, you need to download roughly 100 megabytes. Pulling these images from remote is going to be, we're talking about a couple of gigabytes. I don't think it's going to work on this in the network, so probably Ben is going to demonstrate how he can do it a lot easier way. This is the easier way that I'm talking about. You don't need to download source code.
Yeah.
One command line, and then we're done, so maybe he can demonstrate it. And after that one, and
I think I'll just talk about where we've deployed it briefly.
CyVerse and Anvil,
Yeah, just a quick overview of how we launched the application there.
and then we're going to switch to the new question where we're going to talk about how we can actually use it.
Yeah, and we'll use the instance that we've put up for the workshop. Yeah. Okay. Yeah. So what we just went through was like building all those images locally. So for the back end and front end, we built that locally, which obviously is time consuming. So there's another way. We've also published all these containers, these images online with the Docker Hub. So they're freely available from that repository, which means we can just pull those directly into our Docker Compose file instead of going through the whole build process. So if you had Docker up and running, I was going to say stop the containers with the Docker Compose down. And that's going to stop any containers that you had running. It can take it a few seconds sometimes. Okay, and now when I run that docker ps-a command, we can see that hello world container from earlier, which I'm removing now, so no containers. So go ahead and create a new folder.
You're going extremely fast.
Oh, okay, my bad, yeah.
You can just slow down a little bit.
Yeah, okay,
I think probably you can just review whatever you just went through.
yeah. So I ran Docker Compose down just to stop all those containers that we got running in the last step. When we,
So that one, you just working on is let it run through. But what he's doing here is that he's gonna shut it down, and he's gonna show you how to deploy a services from Docker Hub instead of from local source code that is just here.
Yeah.
So let it run, and once this one you run, I think we can just go to that open up the browser, go to the localhost 8000. You can see that that was running later.
yeah,
But he's going to demonstrate it the other way of doing it. And we are not going to do this together because on a slow network it's going to take forever to do it. So he's going to just demonstrate.
yeah. So at this point, I've just brought all my containers down, so I kind of have a clean slate. Nothing's running in Docker at the moment. What I'm going to do is I need to copy 3 files out of our directory. I need to copy docker-compose.prd for production.yml, and then I need to copy our backend.env and db.env. And so I'm going to copy these 3 files into a completely new directory that's outside of the source code that we downloaded earlier. So in my case, I already have D2S remote. And so this docker compose.yml, that was that docker compose.prod.yml, and I've renamed it to just docker compose.yml. And the db.env and backend.env, all that will just stay the same. We don't need to make any changes there. The only change we have to make is on the front end. So let me pull this up side by side so you can see the other. Okay. I think you can kind of see that. So basically, this is what we were working with previously, and you can see we have that build argument in here, and that's where it's telling it we're going to build this container locally. And we give it the location of the Docker file that it's going to use as the instructions for building that image. So essentially, in this other Docker Compose that we're working on now on the right side, we've removed that build line. Instead, we're just stating the name of the image that we want to work with. And then also, we do that same process for a backend because, again, that's another container where we were building it locally. So now we've replaced the build statement or just completely removed it, and we just have image with the name of our image. And then the last one will be, scroll down. The last change we had to make was in this proxy one where we're mounting a local volume containing our proxy's config file. We just removed that volume because we're also using a remote image now for the proxy container. Before we were pulling in a remote image from Nginx, the people who create the proxy software. We've rolled out our own version of it though that has our own configuration file already built into it that's needed for kind of routing things to the back end and the front end. With our application. And so again, we just have an image, and this time we're pointing it to our GDS lab that's our repo on Docker Hub, and then this is just the name of the image hosted on Docker Hub. And so that's it. With those three files, oh, yes, go back one, DS remote. So you can see I've got those three files, and I'm able to write Docker Compose up. And in my case, I've already downloaded these, so this should go a little faster for me. Yeah.
So the biggest difference here is that now you are not building container locally. You're pulling these images from Docker Hub and just running the local machine.
Yes.
So you don't need to go to the cloning your GitHub repository, Docker Compose, building images. You're just pulling already built images from Docker Hub directly. So all you need to do is copy those three files to that directory, Docker Compose up -d, and that's all you need to do. And then you're going to have the service up and running. Of course, it's not going to work on your laptop because you're on the phone network. Because he downloaded already everything before, so he's using this why he's fairly quick. But if you do it right now, it's probably you're not going to be able to get it done in 2 hours.
Yeah. I think I was missing the remote name. So previously I had it set like this, which is just going to look at the local images we have built and use those, which is probably why it was really fast. If you want to make use of our remote Docker Hub, you do need to have the prefix of GDS lab in front of the image name. And I can show you that, Docker Hub page itself. And you'll see in the book, this is basically what I just went through. I have it all very detailed in this documentation right here. Let me just go to Docker Hub. Organizations, repos. And so here you can see we have our three images that we've published for the backend application, front-end application, and this proxy application, which is this kind of situational on when you need to use that one. Okay. But yeah, so this is what we wanted to show you. Obviously, this is a much faster way to deploy it if you don't need to make any change. Really, if you're not intending on making any changes to the source code, you don't need to build it. Locally, you can just go straight to using the remote ones, which will keep in sync with whatever the latest version of the code is on the repository GitHub. Okay. So I think the last thing we just wanted to talk about then is just kind of some of the places where we've deployed this using these Docker containers. So one of the big ones is we've deployed this on the Anvil composable subsystem. So Anvil's a supercomputer here at Purdue University. And the Anvil composable subsystem is kind of a platform that's based on Kubernetes, which I'll talk about Kubernetes in a second, for allowing researchers to kind of self-deploy their containerized applications on demand. So you can, and what Kubernetes is a system for deploying and scaling your containerized applications. So it gives you the tools and tools so that you can create replicas of your containers. So like if you had a particular container that was getting a lot of traffic and it wasn't able to keep up with that, you can use, Kubernetes has tools where you can just make a clone of that container and then set a load balancer in front of it, which is going to direct traffic to whichever container is not getting the most, which has the most available resources. There's a little more complexity to it, but that's the general idea. Is this Kubernetes is giving you user-friendly tools for scaling applications in like this cloud environment on a system such as the Anvil supercomputer. And they've made this really easy. They were using something called Rancher, which is a user-friendly UI for interacting with Kubernetes, so you don't actually need to know any like of the command line Kubernetes code, which honestly, it looks a lot, there's some similarities with Docker. Once you start working with both of these, you'll see the kind of parallels between them. But I will just show you real quickly how we're able to take these Docker images that we just built and deploy them on Anvil's composable subsystem and Kubernetes with Rancher. Let me just quickly access. So this is what the composable subsystem looks like, and we can see that we have access to one cluster Anvil right here. And if I go to my workloads and deployments, this should look pretty similar to you because this is all the containers that we just built and we're running locally. I've essentially, one of the reasons we went with Docker is because it works really well with other platforms such as Kubernetes. Kubernetes allows you to pull in remote Docker images and create their equivalent of a container inside the Kubernetes environment. So here we have our backend, Celery, frontend, PostGIS, our database, proxy, and Redis containers. And if let me just click on one of these. I'll go to the config for the front end. And you can see, again, there's that GDS lab / D2S -app. So that, again, we're pulling in this Docker image remotely when we're creating this Kubernetes container. And the only other things we had to do is we have our environment variables. So just like we did with that Docker compose file, we've set up the same environmental variables here. Resources, we can allocate how much CPU we want to go to this particular container, how much memory we want to go to this container. And then if this container was associated with any storage and we wanted persistent storage, we can, down here in storage, we have our persistent volume claims. So here's where I've made that our database data, our log data, and our user data that's getting uploaded. We have persistent volumes we've created here in this environment, and now we can connect this to these different containers as needed. And the last step I had to take to get this all online was under ingresses. So basically this is telling, we've got that proxy container, and so by creating this ingress, we're saying that we want to open this up to the public, essentially. So they've got this automated system already built into it. So I just have to point it at the container that we want to open up outside of the Purdue network, tell it what port it's running on, and they'll automatically generate, my host name and all that information for me. So when I click on that, I was already signed in, which of course, it looks just like what you built, we had running locally, except now we're hosting this in that Kubernetes environment on Anvil. And so we have all the kind of fun features where, like, let's say, if I'm looking at my front-end container and we wanted to scale it up to 2, I can just click 2 right here. And now it's creating a replica of this. And now we have 2 instances of that running. And then that ingress service we created early automatically is going to be able to kind of direct traffic to these. Which it gets a lot more complicated when your container depends on data, because now you got to start thinking about how am I going to synchronize data across, if you've got 5 replicas of your database. So there's still some challenges with getting it into this environment, but for like stateless containers like the front end where we're not worried about any persistent data, it's very simple, as you can see, to just kind of scale it up. So that's one of the places we've launched, we've been able to get the application up and running. And then the other one, as we mentioned earlier, was CyVerse. And also, as I was mentioning earlier, that kind of Docker containers play really nice with VMs. So in the case of CyVerse, they've given us access to what they're calling Tombstone VM, which I was looking into that, and it's kind of based on OpenStack, which is a platform for cloud services, such as creating virtual servers on demand. So basically, they've created a virtual VM for us, and we were able to go through almost identical steps that we just went through today in order to get the application running on there. It's just a matter of that last example I showed you with those 3 files where we have our environment files and then our compose file. It's just a matter of getting those 3 on the server, pulling in the application and running the Docker Compose up. And then there's a few extra settings you want to kind of tweak when you're putting something in production, but otherwise it's just those 3 files, and it's a very straightforward process. And for that one, I believe it's cyverse.d2s. And again, yeah. And so this one's running our containers just with Docker inside a virtual machine on the CyVerse OpenStack system.
Does their VM take care of the link to their storage system? Or do you have to mess with it?
That's what we're working with them right now to get the data store mounted into our virtual machine. And then once it's mounted into the virtual machine, there should be a way for us to mount it into the Docker containers and start using it. So there's just a few extra little steps, and we're working that part out right now.
So we got an idea, but basically we went through this process of building images, deploying on your local machine. What we are doing is deploying, going through the exact same process on a server where it's already on a network. Once you do it, and now you have an access to this server from pretty much anywhere you have internet access to. Right now, you just go through a process where you can just install on your local laptop. If you hook up your local laptop to public IP, then you should be able to access this one from anywhere in the world.
Yeah.
So was I able to kind of go through the old process? Still working on it?
No,
It's done? Can you
So
open up that localhost 8000 and see that website? If you can have money, open up the browser.
Yep.
So open up the web browser. Type localhost colon 8000. Still running? Okay. Localhost colon 8000. Enter. Oops. I'll probably have to do HTTP. No.
So is anybody can use the Anvil or CyVerse?
We haven't opened those up to the public yet. It was more kind of proof of concept to see the process for getting them running on them. Yeah, so we just wanted to see what steps were needed to take to put them.
So it means if I can if I'm using the the Oracle Cloud, some the Azure or something like that, so I can install the Docker container on that instance on that cloud system. I can.
Yeah. Pretty much anywhere that runs Docker, you'd be able to get it running, or even anywhere that's in a Kubernetes system, you can pull in those Docker images and run it that way. Yeah.
I have to go all through this.
We were recording it actually. We were uploading to YouTube channel.
Okay, so yes, pull it up right now. Okay. I think we can. The time for a demo, or
So, are you planning to do any demo of the platform, or?
I thought Minyoung was going to show off like all the platforms. So.
So I'm going to give you a mic.
Hello. Nice to meet you, all of you. So during the last session, we will do some kind of, I will present how to use our D2S system using the instance and the sample data we prepared for the NAPPN workshop attendees. So the first thing we are going to do is download the sample data throughout the links. So
how big is the file?
Huh?
How big are those files?
It's really small. We were not sure about the speed of the Wi-Fi, so we reduced a lot of the
file size, right?
Yes,
But they're having, taking, minutes to download 100 megabytes. I'm pretty easy,
Let's try it maybe. So just follow the links, and you can see two blue things, and when you click it, you can get the data set. So I think it doesn't take a long time.
And do you think you can download it and copy it to USB? You have a USB.
So actually, we prepared tri-temporal UAS data set for this workshop, but as I mentioned, we were not sure about the Wi-Fi condition. So this second data set just includes just a single temporal data set. But if you need more temporal data set, you can click here and you can get the additional sample data set for the future. So I think how long will it take? Will it take? 3 minutes. 3 minutes, okay.
Oh, you're downloading the data right now? Yeah. Okay. You only says 3 minutes? I'm copying.
It's on Purdue server. So
What is that?
it's on our PS2 servers where these files are coming from.
Okay.
So just let me know.
Yeah, maybe you can do that in a sign-up process.
Okay.
In the meantime.
Yeah. So we are going to access the instance we prepared for you. So click this link or just type these things, and you can go to the instance we prepared and on our server. And of course, you don't have any account for now. We are going to sign up.
You can use your laptop because this is a simple website.
Yes. Yeah.
Open a browser.
Just click it, and you can go to the website. So
Click sign up. Maybe Minyoung, can you show the process?
yes, click the sign up, and you will see this page.
NAPPN.
And fill out with your information. Because I already have an account with my information, so I cannot fill out this form. But after filling out it, just click the create account. You will get an email to verify your email. So email address, I mean.
I think the requirement is that your password should be certain length.
12.
Otherwise, you can repeat too many times in cases. You don't need to use any special data. I think the only requirement is that don't use the same data so many times. I think what is the minimum length?
12.
12.
And when you click the create account button, you will get an email in your mailbox. It looks like these things, and you will see this blue button, and click it, and we have another process to approve your account. So please click the blue button in your email. So go to Outlook and check your email, check your spam, or
Anybody having hard time downloading the sample data? You have a copy?
Has everyone got an email with the blue button? No, not yet. I think. Three? Not you.
I don't know why, but it takes some time.
So it seems like 3 people got confirmation mail.
And then they all come at once.
I'm still waiting. 1, 2, 3, 4, 5, 6, 7, 8, 8. And after for a while, you will get the approved email about your account.
You want to, oh, now you got it. Oh, true.
So those who got an approved email, please log in to the instance. So just log in, and you will see an empty homepage, not like me because I already have a lot of data set. It should look like empty data set. Just so you can see a navy button here and empty map here. So this is. Do you have everyone got?
Everybody were able to log in? I think I need to working on it.
8, I think. Yeah, we are 8, I think.
Okay.
So,
Okay, good.
so we are ready to go.
We're good.
Yeah. So this page shows our home of the instance. So actually, if you already upload your data set to the database, you will see a list of the data set on the left side, and each locations of each project or the data set will be shown in the map, on the map with the pinpoint. And so the next thing we are going to do is upload our sample data set. But just before doing that, we need to understand the database structure of the D2S system. So actually, the first thing we need to set up for uploading our data set, we should make a project. It's a kind of preparation for uploading the data. So project, so you can click the workspace, and there is empty. You will meet really empty place and click the create. And you will get this pop-up window, and you can type the information about the project. And I already with this information. So we are going to upload the sample data set, and the information about the sample data set is as follows. So just type of this data set on the right side of the pop-up window. While you are typing that, we just mentioned the planting date or the harvest date But this is because the D2S system has been developed for to respond to the agricultural applications. But you can type any date, like a project period, so as you want.
Or this is an optional, so you can leave it as blank as well if you don't want to.
Yes, and the other thing, you can see the team banner here, on the bottom of on the right side. The D2S system is focused on sharing the data throughout the members within the D2S system. So if you have make team, you can see the additional option for these things. So I have a team here. We are going to learn how to make a team for a while, but after minutes. But when you create a project, you can assign the existing team to this project. And just leave the no team for now, because you don't have any team for now.
And if you assign a team, any member in the team will have access to this project. So let's say you are the owner. I don't want to share this data with anybody. Just assign no team, then you're going to be the only one who will have access to data. Even we cannot see the data.
And the project is defined by the special reason in which you are interested, and you need to draw their boundary on the map, or you can upload the shapefile of that boundary. So click this. If you don't have any shapefile for your study site, you can draw the polygon like me, and this will be your field boundary of the project. Or the other option is the upload. You can upload the shapefile here, and you can drop the shapefile. You download it from the links. So one thing you should be careful is that the user of Safari usually automatically unzip the zip file, but this process needs a zip file for the multiple shapefiles. So you need to include all the files into one compressed file. So if you have unzipped files, you need to compress all together into one zip file and just drop it. And then you can click the green button to upload the data set. So as you can see, the small blue box on the field, so it indicates the field boundary of the project.
Is it possible to draw the multiple polygons in single project?
If you upload a shapefile that has multiple records in it, you'll be asked to pick just one of the records from that. But if you had like a single record that was multi-part or something, like I think that should still be able to display. Yeah. When you're drawing it manually, though, you're going to be limited. Just like one connected polygon.
We can use only the single polygons per project.
So this project is, the way how we define this project is, this should be a one continuous spatial area where of course we will leave the data on. We pick from multiple fields, and we recommend to put in separate project. And is everybody able to actually upload this shapefile?
Is that a zip file, not the individual shapefile?
No.
It needs to be zip file.
Because the shapefile is the format where you need to have a multiple file. So I think we can implement in the way where we can select the multiple shapefile into one, but we just decided compress everything in a single zip file, and we just upload the one single zip file.
And click the create button to make them project.
And when we create the shapefile, when we use the uploading functions to upload the shapefile, so do we need to define the specific coordinate systems, or it's going to be converted automatically?
If you give us a PRJ file with your shapefile, we'll be able to convert it into like WGS84. Yeah. If we don't have a PRJ file, it's going to assume that, though, you can run into, yeah.
So we just assume that the shapefile has all the mapping, information. not a big fan of shapefile because it's not open format. It has multiple parts, and there are much better one, which is GeoJSON, which is a single text file.
And that's what we do is we convert your shapefile into GeoJSON, and it's actually saved out in the database.
Dumb question, where I get this shapefile within this thing, I mean, when I go to my real scenario?
Oh.
In this case, you can draw it if you know the area directly. You don't need to know the shapefile.
I don't need to, okay.
Yeah, you can just, delete that, Minyoung, can you show that, delete that polygon divergence and unload it? Can you delete it?
I think so, yes.
The click finish,
Click finish?
or click the eraser tool, now click on
Select
it.
that one?
and now
Okay.
finish.
Yeah.
And you can
And,
draw.
yeah, just draw on a map directly.
Okay, understood.
Yeah, and in a lot of cases, you already have a shapefile. Okay, you don't need to draw. You just unload it directly, so we don't need to click multiple times. And another important thing here is that you need to draw a boundary where you're going to collect the UAV data on. This is the area that you assume that all your ortho mosaic is going to fit inside the polygon. And if somehow you could draw this polygon here, if your UAV data is uploaded to some complete other location, you're not going to see that unless you just zoom out, move all the way to another location to see it. So this is the area where you can find a project. What I mean by project is this is the place where you're going to have multiple UAV data collection that happens throughout the whole city.
So I think everyone has a.
Yeah, we need to upload the shapefile. Oh, you're ready.
Yeah. So let's click the first thing. I think you just have only one project, and on this page it shows the information about this project. So what you can do here is you can edit the information about the project when you click each pen icon, or when you click this map icon, you can modify your field boundary data set. So you can, anytime you want to modify it, you can do it. And also, for the team, you can assign your team here, like to click the pen icon, and you can find your team in your list and click them and check it. So then your team member can see your data set in this project. So what we are gonna do next step is add a flight for our UAS products. So we need to add new flights here. So the information about the flight of our sample data set, I already. You can go to 2.3, manage UAS data products, and go to upload UAS data. Oh, sorry. Excuse me, I think I lost. Okay, this one. 2.2, add new flight, and there is information about our sample data. So you can fill out this form with these numbers and information. But this is just for demonstration. You don't need to keep correctly. So just.
Yep. Let's try to stick with the information that is provided. Because there is some fun exercise that we'd like to do later. So Minyoung, maybe you can just demonstrate that process. 40-meter altitude, 85 overall. Sensors in RGB, include the panel 4.
Yeah, and one thing I want to mention that you can just see your name in about the pilot field. But once you assign the team into your project, you will see other members within the team, and you can select one of them as a pilot.
And the Minyoung created NAPPN team before with the 3 of us. That's the reason why she assigned this project to that team. That's the reason why those 3 names shows up. In your case, it's assigned to no team, probably only your name is going to show up.
And when we click the create button, you will see a card image, the small box about this flight. And actually, we can switch this view type by clicking these icons. So when you click this table, you can see the flights in a table view. And when you click this one, you will see the carousel view. So you will see the next, but if you have a lot of data set, you will see it looks like this in this way. So you can see all of your flights in a row in terms of canonical way. And also you can see in this into one table if you have a lot of flights. So go back to here, and now we are ready to upload our sample data set. So click the Manage Data, and it will bring you to the data page, and it's empty because we haven't uploaded any data set. So please click the Upload Data and prepare the data set you downloaded from the links. So if the files are zipped, please unzip the file for the sample data for uploading, and unzip that. And we are going to upload DSM file within this directory. So click the DSM and just drop it. And check the file name is correct. And please make sure you need to, You need to click the data type for the files. So I clicked the DSM, I dropped the file of the DSM, and I click the green button to upload our data set. So now, you can see the uploaded data set in this small box. The files, this file name indicates you already uploaded this data set. And we are going to do the same thing for the ortho images from the RGB sensor, and this one also. We can do a browse files also, and you can drop it, or you can search from here. And I need to go, and you can see, okay, click the ortho and upload, and you will see. And don't forget to change the file type, data type here, and upload it. It takes 4 seconds, I think.
In your case, it might be slower. She's on a quick network, you're on a gas network. You may go a little bit slower.
Okay. Ortho RGB.
When you upload this data, you may think that you're just uploading, but there's a lot of data processing happening in the back end, so that we make this data set available as in a cloud optimized data form.
So within the sample data set, just 2 data, DSM and ortho, are created from this flight, the RGB sensors. So we just drop 2 files and click the Done It. You will see you will see the uploaded data set in this page. Okay. Actually, soybean field, and
in terms of the DSM data, the color is going to be the stretchable, actually.
We'll talk about it.
Oh, okay.
We need to take another flight.
yes, but I think we need to move. I will add all of you to my project to reduce the uploading time. Yeah. So let's explore my teams first. So this section, when you click the My Teams, you will see the team page, and you will see the list of your team in the left side. And when you click the Add a New Team, you can create your own team. So you can do actually these things. Okay. And it's optional, so we can skip it. And so of course, I'm in the team, and you can search from here, and you can see all the accounts existing in this instance. So I will select all to my team and add selected. And as you can see, I'm an owner, and others are just member for now. And then I can click the done. But just before, because we have the project to share within this team, we can point out the project you want to share within this team at this moment and click the done. And you can go to the workspace, and you will see the two lists of the project like this. Workspace. Can you see the new project? So with the all. No? Oh, okay. Okay. We will do another option for the inviting the team member. So you can go to the in your project page. You can click the Manage Access. This means you can manage all the actions about this project, and you can add members here. So I will go to.
Did you have another team already assigned to that project? If you go back.
Oh, yes. Oh, should I switch off?
Yeah, try here, I think.
Okay.
Now if you click Manage Access, let's see.
Yep.
Okay, it's because another team was, if you only have one
Okay.
team associated,
Ah.
back.
So there is some kind of.
So only one team can be assigned per
To a specific project.
Yep. But you can add an individual member.
Oh, okay.
Yeah. You can remove,
Going to manage access, that when you assign this project to a team, all the members with the team will be added as a member automatically, but you can go to manage, access here, you can add a member outside of the team.
So now you have all the sample data set we provide for you today. So we are going to explore what kind of things we can do with D2S system with this sample data set. So we are going to select the most latest one in July about the RGB, and please go to Manage Data, and you will see the three different images of this flight. But I will deactivate. Okay, okay. And when you click this view, it will bring you to the home page with this. We can visualize this data set on the map.
And it will look different because this view is tied to your account. You can go ahead.
Are you share? Do we share the color information?
Their own custom view, but this is the default. Everyone will get rainbows. The color rank by default will be set to the min and max value of the data set by default. But then if you make changes.
So when you see the just one band rasterized image, you can select the color maps in this list, and we can do anything you want. And of course, you can set the color range to as you want. So like this image shows according to the minimum and maximum values, but you can change with the average mean value plus minus standard deviation, and you can set the 2 or 1, any number you want, and apply the change. You will see a different color.
Let's change the color map to something different.
Okay. And this one will show the different, I guess. Okay. So you can customize the visualization of your image.
And don't forget about the same changes. This is temporary.
Mhm.
You don't save it, come back later, you can go back to the
Yep.
default view. So if
So-
you want to keep this view, you need to click Save Changes.
If you like this view, just click the Save Changes, as he mentioned.
And next time you come back, you're going to see exactly the same view.
So can you go back to the workspace, because I want to mention another function we have. So for the ortho image, actually we can do a view also, and we can do some kind of bandmass with our data set. So this is just for 3 bands RGB image. So we can do extract the excess green vegetation index, so-called EXG, and you can set the, and if you click the run, be sure about you correctly set the band number for each channel. So red should be a band for the red band of your data set. So you need to check your data set's band composition. And click the, yeah, but I think we have another one. Okay, we have 2 different EXG, because I already did for my manual, for writing my manual. So now you have the EXG vegetation indices within your database.
You cannot see the toolbox because you're the member.
Oh,
But if you go to your project, you know the data. Open the that for you is the toolbox.
should I change one by one?
No. They have their own. You have onboarding your data. You go to your project. Workspace, go to
One by one, should I?
see the toolbox there, right? I think.
I'm just curious.
Were you able to upload data?
Yeah.
Oh, okay. I guess I'm confused.
The reason why we set this as a band number to be specified is because depending on sensor, some the sensor, the process software, especially the RGB in Gen 1 to 3, some sensors in 3 to 1, etc. So it depends on which sensor package you use, and you need to choose the specific band combination.
Mm-hmm. And if you
Yeah, so you're not going to be as the owner of this one or manager. And you're not going to be able to do that in a process.
Oh.
You got an idea.
Actually,
That's one thing about the teams. Whenever you get added to a project, everyone's put in under viewer role, which means you can just view data. So from that manage access page, though, like if we wanted someone who was on a team specifically to be able to create products or edit products, then you could upgrade them to manager under that page.
so I think I upgraded you as a manager. So now you can do the band mass. I thought I just saw the Kim. Okay, so now you can do band mass. So in terms of the multispectral image, we can do another things, the NDVI. So you can just click this thing and specify your band number for each channel and just run it. You will see, you will get the NDVI image of this data set.
So how did you edit the NDVI part? I didn't see the EXT and how.
Oh, you need to select a multispectral.
Yeah, multispectral, for just multispectral image. So, okay.
You need to create a new form.
Okay. I think, but I will change all of you. Mm-hmm.
But everybody's generating their own NDVI. You're going to see a lot of NDVI. Is that how this is going to work? Let's say that
Yeah.
Bibles are generating
We'll make a new data product for each operation. So
But you can see the toolbox, the NDVI channel within the toolbox anyway.
So choose multispectral. Click this one. So you need to go to workspace. See the ortho here, toolbox.
the part that I'm talking about. This is, we like to do this as an open system. So we're going to probably implement more vegetation pieces to be added. We just implemented an EXT and MDR, we can add more. But if you have your own, the indices or any further process you like to do, we don't have that system yet, but we like you guys to contribute back that, whatever I develop that system structure so that the others can use it as well. But, we just have those two, but we're going to start to add more in the future.
And within this data page, you can go to another flight by clicking the icons on the left. So you can go any flight in the list by using these icons. And the next thing we are going to do is see the RGB band, also image, on the map by clicking view. And okay, I need to do not this one, multispectral one, sorry. I think we need to do with the multispectral. And for the July one, and a lot of NDVI, okay. Click the ortho mosaic, and you.
Sorry to interrupt, but all this processing happening on the server side. Your laptop is not doing any processing, and you see how fast it was. Right? Yeah, that's right. Because all the data is on the server. In the server, we have a pretty decent CPU and lots of RAM. And once you click it, it's going to be pretty fast. And your laptop doesn't need to do any computing, and that's the advantage of putting all your data to close to your computer. Once you click process, the process is a lot faster. You don't need to download any data. And then we're going to talk about how you can actually access this data, not only browser, in any GI software we're going to talk about later.
Yeah, and one thing I'd like to mention about the band composition, you can change the band for any band within this data set to make the shadow color image. So I'm not sure.
It's a 512.
512. So we are going to make a shadow color, and as you can see, the vegetation is more distinguishable compared to the RGB, just RGB data set. And
one more thing that I mentioned is that this is a data set collected from multispectral, and if you guys have any experience with multispectral, they collected a 10-bit. So it is not 0 to 255 anymore. 8-bit is 0 to 255. 10-bit, you go all the way from 0 to, I think, 30,000 something. So you see that max value is not 255 anymore. They just get those new max value automatically from that data. That's a 16-bit, but I think the actual data range they use inside the file is 10-bit. So actual, I believe the number of range that is meaningful is only between 0 to 34, 32,000.
That's how we NAPPN.
Yeah, 0 to 1. That's exactly that. This is already making calculate data.
And also you can zoom in and zoom out, and you will see it's really fast to zoom in and zoom out because we are using the cloud optimized technology about this image. So even though, because our data set is so small, so small for now, but if you are when you use a large data set, you will see how fast you can see the data set within this web page.
How can we get plot-wise NDVI?
What's that?
How we can get plot-wise NDVI?
That's something we're going to implement. We don't have it yet, but we're going to demonstrate later. You can load this image to QGIS without downloading it. We have a QGIS plug into the plot boundary delineation.
Right.
You can do the zone specific within QGIS. So now this is the part that I'm going to talk about. Probably she's going to show it, but you don't need to download the data. You're going to share this data to QGIS, open up this layer without downloading it, and you can just see everything inside QGIS.
And the other thing,
So you can do whatever processing you do inside QGIS, do it that way. We are also developing a Python module processing all this data. So you can do Python programming. You can access all this data inside Python as well.
Python password, you need to authenticate yourself, and you're going to be able to see all the flow data, all the file, all the data, and you can just do the Python programming using that program as well.
So you can customize the color map and range of the color, and you can RGB composition for the visualization. And the other thing we can do is the visual comparison between the multi-temporal data set. So you can click this balance icon here, and you can, so now you can, you have two additional boxes on the left and the right side, and you can switch to the other stuff within this project. So we are going to choose the June data set, and as you can see, you can directly compare how different the multi-temporal data set are. So just swipe right and left, and you can see how different they are, how much they are growing up during this season or something. So any data set in this project you can import for the comparison. So like EXG, so you can do.
Sure, of course. This is open. So we are open. If you have a video, take a picture, whatever you want. Please spread the word so that people can use it.
And also our D2S system, you can visualize the points cloud data. So we are going to select the points cloud data in this list. So, and when you click the LiDAR data set, and when you click the points cloud, sometimes it happens. Okay. I'm not sure what happened to this. Okay, it looks like this. And you can find more functions about the point cloud here, and click here, and you can see the tools. And what you can do is zoom in and zoom out, and you can measure the plot, you can measure the distance between 2 points, as I did. So
Right-click and pen is going to be 3D rotation. So this is 3D view, not 2D.
So you can do rotate, and you can see all the points in the points cloud data set.
Where does the green color come from?
So it's RGBD LiDAR, I guess.
So we find the DJI L1, so there's an RGB camera from the color.
So any type of point cloud will be accepted, like from LiDAR sensor or from the image-based 3D model.
The input, you are just looking. We are doing all those, we are combining this, last time to cloud of point cloud format copy, and we also combine this. And Ben, are we combining the endpoint format as well?
Yes, because that's what we need for displaying it in the browser.
This cloud optimized point cloud format standard is kind of they compete each other. There's an endpoint, there's a cockpit. So we are combining into both versions right now. And whoever we probably want to stick it to the only one. But right now we're combining.
So can we on the last pile or last pile?
Do you take the LAZ as well?
LAZ?
Because what we use in the P-line in the back end.
Oh, okay.
So I think it doesn't matter whether you're more than LAS or LAZ. I think both should work. Give it a try and let us know.
Oh, okay.
What will make it work?
So this is pretty much about our visualization tool. And next is about how to share the data to someone who is not within this D2S instance. So when you click any data set you have in your database, you will see this share button. And when you click this share button, there are two options for sharing to others. So one is restricted, and the second one is anyone. So the restricted, as it says the restricted is the kind of the someone who received this link can see limited way of the data set. So when you click the restricted and copy the links, as it automatically copied to the link, and when you paste it, you can see the image you received. So.
Because you log in as you.
I think, yeah, I need to log out, I think.
So you can open up a private.
Should I log out?
In the map or download the file?
Pardon?
You're trying to view it in the map?
In the map? What?
It was downloading the data set.
Yeah, I think it's weird. So we are going to open this one. Okay.
Because you're not logged in. You're not logged in yet.
But
So you haven't logged in. So you
yes,
so restricted. So you cannot, even though you share the link, that person cannot see it. Right.
okay, so
You have to click anyone.
okay, let's try anyone. Sorry for it. Okay, copy the links, and these links will anyone can manage this data set. And actually, when you, I'm not sure about this.
You're downloading the data.
Okay?
So
No, okay. We are going to.
Let me show you. I think the way how it works. If you just give me a second.
Sorry, I haven't shared my data to others with my links actually.
So where is? Oh, you just. Safari?
네, 근데 네, 옆에
So if you do the restricted, there is an option where you click include symbology, meaning that whatever the view that you set, I like to share this symbology as well. So one way of doing it here is that, let's say I like to change DSM here, and I like to set my color to be earth, and it's to be min max and apply changes. Let's say that this is the view that I like, okay? And I like to share this in a specific view that I shared, and I click copy, and click anyone, and include the symbology here, and copy this link. And if you send this link to someone else, now anybody who has this link can see this in a page. So if you just go to Safari here, try the private the view where I'm not logged in here. If I paste this link here, and you see it, then they're gonna actually you see that I'm not logged in here, right? Let me just view. You see? Now I'm not logged in here. You see that I'm still seeing the sign in button. But that person can actually see the view that just created. Okay? You can just do it that way. But if I go back, probably here, I'm gonna change this into restricted. Then going back here, I try to refresh it. Now I don't see it anymore because you just remove that access to that file. I changed it to anyone to restrict it again. Does that make sense? Okay. And the other thing is that, do you have a QGIS installed here?
Yes.
Okay. So the other one here is that, let's say I like to load up this DSM that is created inside the QGIS. What you can do is that we are still working on it so that you can access this file with an ID and password. We don't have that in a way yet. So if you like to access it, click in anyone. Don't include the symbology, because in the QGIS, you like to do your own styling over there. You just make it available to anyone, copy link. Then I'm going to run QGIS over here.
It takes for a while.
Yep. Then I'm going to click add raster, HTTP
paste the link that you just copied. Click add. Now you see that, you are actually streaming the layer from the server to the QGIS using cloud optimized UT format. So even though this is at 100 gigabytes, it's going to show up, right away, because what they're doing is that they create a tile in the back. So you're only showing at that specific zoom level. Usually there's going to be only few hundred kilobytes. So they're going to be only streaming the few hundred kilobytes at the time they're looking at. As you start to zoom in, they're going to start to send that the higher resolution only for the portion that you're looking at automatically. So you can just load up here, and from here you can just do the same thing. I just do the the pseudo color, and I click apply. Then you're gonna see everything over here. If you have any plugin, that have any shape file that has all those plot boundary, we do have plot boundary plugin created, make it available. And for those of you who doesn't know, if you go to plugin manage here, click all plot boundary. See, this is the tool, plugin that we just created here. Click close, and then click here. You just selected a layer that you like, specify where you want to save it. Let me go to desktop, test shapefile, or GeoJSON, and I'm going to create the 2x5, and I'm going to click this upper left corner, and it's going to be 1 by 1. Spacing is going to 1 meter. Constant is in 1 meter. Rotation angle is going to be 2 degrees. Click generate. You see that they generate automatically here. And if you are if you are field manager, you know what is the plot width, plot length, what is the column spacing, row spacing, what is rotation angle. You just keep trying. You just align your those plot boundary with the location. We can do the donor specificity here. And the beauty here is that all your data reside on central space. Now you don't need to worry about where is your data. It's already uploading everything to the place.
One thing that I noticed in your value range from 187 to 189, that's too narrow.
Because this is a soybean. So soybean is not growing that tall. So soybean.
That's the height?
Yeah, that's the height. This elevation model. That's the reason why we are looking at a very small area where soybean is somewhere around a meter-ish.
Canopy height.
Yeah.
That's the centimeter unit?
Unit is in meter. Yeah.
So how do you want to add that metrics, the plot level metrics extraction into your cloud?
You already have a code. You can use Python. It doesn't matter. You need to read to the way like we saw. Generate an NDI. So there's going to be some plugin to be added into the web platform. You already have you implemented a web version before. It's going to be just matter of on our platform. And that is going to be always, that's one way of doing the platform is remediation. One of my grad students is working on automatic detection of plot boundary based on the different hydrogen sample that we can send basic matter. We actually developed that one. It works pretty good, and the result is showing that it is actually a lot better than doing manual way. So probably we can implement that in the server side, so you don't need to import the QGIS anymore. You can run it in a plot boundary remediation and all that. And we already have NDVI. You can implement the channel cover, the channel flag, everything. The process can happen on the server side as well. Eventually, we'd like to go there. We are not there yet. That's the part that I'm talking about. We are building this as an open platform so that we're going to provide this to you, but we also like you to develop your own algorithm, contribute back to this community so that others can benefit from it.
How can we contribute? What platform you going to?
So any code that you develop, we can integrate in the
how do we provide our development right into your
So that is something we try to establish. We don't have it and have
probably either it's in the either it's going to in the form of GitHub repository that is in the public, where all your code, you already make all the code available through the GitHub repository. You just download the zip file, share all your code in the local machine. If you just dig into all those media folder, all those code is already available. So if you make any code changes, we'd like you to push your changes back to us so that we can review. And if you just look everything okay, then we're gonna merge your changes into main branches, and we're gonna probably update our Docker images and make it a newer version. And the next time people deploy, they're gonna have all those new features being added automatically as well. So that's one way of contributing your code. But the other way of contributing is contributing your data. If you make your data unloaded to this cloud, make it available to anyone. And we haven't talked about it yet, but we are also implementing tech services, spatial temporal archive catalog. So we're going to be working on a way for you to publish your data to step in public catalog, so that if you publish it, and anybody can actually grab your data and they can use it for their research as well. So we are looking for two types of contribution. First one is your code in the algorithms. Second one is your data.
Are you planning to make a Jupyter notebook platform so that attendees can?
Yeah. That could be another way of doing it. So, like I mentioned earlier, we are working on developing a Python module to access all this data set. Once you develop this, we can create a Jupyter notebook. And now we can actually, do all the code in the Jupyter notebook. We can share that Jupyter notebook with us, and we're going to get this Jupyter notebook available for everybody. So we like to, build this platform as open as possible, so that anybody can contribute, back to us in terms of, the code, data, or just giving us feedback. That's another way of, the contribution we can communicate.
I thought this is a way to process the huge type of data on the cloud.
Sorry, Minyoung, I kind of hijacked your session.
I think it's pretty much
any,
about our data set.
anything else you had in mind to talk about?
Not really.
Do you have any plan to expand this kind of platform for different type of the data, like indoor, like ground images or the video streaming, something like that?
So I mentioned earlier in the workshop, so we only work with the UAD data set at this moment. Basically, it doesn't have to be any type of spatial data. But we are working with another group here at Purdue, Dr. Diane Wang. She's a Brazilian research scientist. She collects a lot of field sampling data. They developed a programmable way of send all the field sampling to the database. So we are going to actually start meeting with that group Harvard starting tomorrow. So we're going to talk about how to integrate your field samples into this platform. So we will have height measurement on the field. We're going to GPS. We're having height measurement when we're going to have a programmable way of incorporating that information into the database. We are also working with Purdue Ag alumni phenotyping facilities. We're doing an indoor phenotyping. So we're going to work with that group to incorporate indoor greenhouse phenotyping data into this platform as well. So we try to cover pretty much all aspects of phenotyping. So the manual phenotyping that can be covered. We're going to do the greenhouse phenotyping that is going to lead toward this field phenotyping using UAV as well.
It doesn't have to be phenotyping specifically. It can be a disease detection or crop pest monitoring using satellite imagery as well.
We just got a funding from the APDC to incorporate satellite images into this platform as well. So satellite images is going to come into integrate into this platform in the coming years.
So are you going to add more the processing modules like classification, something like that on this platform?
We will add. But I want you to send your data code to back to us, so we can incorporate yours into our platform as well. We can
like I mentioned, this NAPPN.d2s.org is going to be up and running. There's no stories in it as of now. We play with it. If you see any bugs or anything, let us know. We'll get it fixed. And we spread the word so that people who need some kind of some platform like this, we spread the word so that we are in the process of developing some kind of service. So let's say, for example, USDA, you like to have your own, isolated system to do this kind of, data, management. We are in the process of, providing those kind of services to, the external entities. So that we're going to deploy all these services, but you're going to be the actual, owner of the system. You're going to have full control. So we can call it whatever you want, USDS.org, or whatever domain that you would like to have, that they're going to have isolated, platform where you can have full control of your, the data set. So that this can be deployed in, like we're doing Purdue server, we can deploy it in the AWS, Oracle Cloud, Microsoft Azure, Google Cloud. It really doesn't matter. Any further questions? Thank you very much. We are actually finishing 40 minutes earlier than we anticipated, but I know that pretty much everybody's already gone because I think all the other workshop is done at 5. So thank you very much for coming. And like I mentioned earlier, we are actually recording everything that we are doing here. So this camera is off. Probably the battery is dead. But I think the audio is at least recording. So we'll upload this in a recorded video to our YouTube channel. Probably going to send out the email as well. Thank you very much. Enjoy your rest of the NAPPN conference. Hope you're up.